To live on Mars, we must terraform it, but terraforming Mars will be no easy task, because first of all, there is no air pressure on Mars to stop water from evaporating at a very low temperature. And since Mars has no notable magnetic field, we can be exposed to high amounts of radiation. Also coupled with the extremely cold temperatures on Mars that can turn carbon dioxide in its atmosphere into snowflakes. The Martian atmosphere is made up of 95.32% carbon dioxide, 2.7% nitrogen, 1.6% argon, 0.13% oxygen, and 0.08% carbon monoxide, and other various gases. Mars' regolith, a loosely arranged bit of soil that covers Martian bedrock. It gives Mars its signature red look by housing tons of iron, which rust. Even though Mars' soil is rich in iron, you shouldn't touch it because it's incredibly toxic, because it has a chemical compound known as perchlorate that's absolutely everywhere on Mars, about 0.5%. It may not sound like much, but that 0.5% can still kill you. A living space is needed that can protect us from the harsh radiation the Martian atmosphere cannot keep out. We also must find a way to get water from the ground and turn it into oxygen and drinkable water, all while we genetically modify food to live on the toxic soils of Mars and maintain supply drops.
In order to survive on Mars, we would have to build buildings. So we would build sleeping quarters, a communal hall to encourage conversation, because some people could be feeling alone, and conversation is the best way to help people feel at ease. A science lab, so that we could conduct experiments about Mars and send samples back to Earth. A garden/green room to grow food such as fruits and vegetables. An oxygen generating factory to thicken Mars' atmosphere and add oxygen to it, so that Mars could be a habitable planet. A telecommunications satellite dish to communicate to Earth in case anything goes wrong, and so that we would know when supplies are arriving. To ensure that everyone stays sane, we will have a large communal hall where everyone will be able to talk to the other people there. This will help people develop new friendships and reduce stress. Everyone would need to use a resistance machine in order to stay in top physical condition and help bone growth. We would need the Mars Oxygen ISRU experiment, otherwise known as MOXIE. MOXIE will use solid oxide electrolysis to turn the carbon dioxide in Mars' atmosphere into oxygen and carbon. This is good because the carbon can thicken Mars' atmosphere, as well as we can add oxygen to the atmosphere to eventually make Mars habitable. Using this technology, we could make an oxygen generation factory on Mars.
The Mars 1 rocket will be using a new rocket engine developed by SpaceX to get to Mars. The engine, called Raptor, is the most powerful rocket engine ever made. Using liquid oxygen and a liquid methane fuel mixture, the engine provides 738,000 pounds of force in the vacuum space and 690,000 pounds of force at sea level. The current plan is to have 42 of these engines power the main 254-foot tall booster to get the spaceship into orbit. The spaceship, 162 feet tall, will have 9 of the Raptor engines. Once the spaceship is in orbit, the booster will turn to Earth and have a propellant tank loaded onto it before returning to space. In space, the propellant tank will fuel the spaceship. After the ship is refueled, it will begin its 80-day journey to Mars. Comfort was also thought about in this plan, as the spaceship will have room for 100 pioneers and still have room for the cinemas and other activities. Several trained astronauts will come on the trip to make sure everything goes smoothly, like Gregory Chemtoff, an engineer in case repairs are made, David Williams, a physician to assist in medical problems, Robert Bundair,